Hi, Chris Kuzmal here. We're now continuing with relational analysis, and we're looking at tree-based search. Imagine a natural tree, such as we see here in the winter in Kansas, and actually optically, I stretched it out to the left and right for no reason other than to fill the screen. And now turn that tree upside down, and we have a structure that we call a tree in computer science. And that structure helps us decompose problems. So let's consider the case where we have the challenge to determine the satisfiability of the logical sentence A and B imply C. Let's assume that A and B is in parentheses. There's no question that that's the antecedent A and B together. And so if we're a little clever, we can notice that immediately that if not A holds, then the entire logical sentence is satisfiable because because there's the conjunction, and the not A immediately makes the whole conjunction false. And if the conjunction is false, it means the antecedent is false. The antecedent is false, then the whole logical sentence is true. So only by determining not A is all that's required to determine that this is satisfiable, or to identify what can satisfy the logical sentence. Now, of course, if that's not an option in your exploration, or because you chose to evaluate A first, then that decomposes or simplifies the problem, reduces the problem to determining the satisfiability of B implies C. Here again, if you spot that negation of B satisfies the sentence, then again, you've been able to avoid doing a large amount of search. Of course, it's possible that you may have the constraint that A and B are both true, in which case, the only good news is you've reduced the problem to the satisfiability of C all by itself. And so if C is true, then the sentence is satisfiable. If C is false, the sentence is not satisfiable. But that's only on the constraint that A and B are both true. This shows you how to explore every option, but also shows that you don't have to explore every option necessarily in order to get the solution you want. Now here, it was relatively easy to find the satisfiability of the problem. What if the problem were the opposite? What if trying to determine the satisfiability of the negation of that sentence? Then there's only one place you could get to, that one green triangle down there at the bottom, that satisfies the overall logical sentence.